All right, today we are going to tackle one of the most fundamental ideas in all of mathematics, set theory. Now, you might not even realize it, but this is the secret language behind how we group, organize, and, well, make sense of pretty much everything.
So let me ask you a question to get us started. What's the real difference between, say, a grocery list and a list of the most beautiful people in India? I mean, they're both lists, right? But mathematically, one of them is a proper set and the other one isn't. And the reason why is the whole point of this explainer.
Well, it all boils down to one single, really crucial rule that separates just any old collection from a true mathematical set. And that rule is all about being well-defined.
And here it is, the official definition. In math, a set is a well-defined collection of distinct objects. That little phrase right there, well-defined, that is the secret sauce. That's the rule that changes everything. And this right here perfectly shows what we mean by well-defined. You know, if I ask you for the vowels in the English alphabet, you're going to say A, E, I, O, U. If I ask someone on the other side of the planet, they're going to say A, E, I, O, U. The answer is fixed. It's universal. But the most beautiful people, my list is going to be different from your list. It's totally subjective. It is not well-defined. And because of that, it's not a mathematical set. Okay, so we've got the what, we know what a set is, but how do we actually write them down? Well, mathematicians have a very specific language for this, and we're going to look at the two main ways they do it. First up is what's called a roster form, and it's exactly what it sounds like. It's the most direct way. You just list every single element out, pop some commas in between, and wrap the whole thing in these curly brackets. So for the set of natural numbers up to 7, you just write them out. Easy, right? But you can probably see the problem here, right? What happens when the list is just huge? Or what if it's literally infinite, like the set of all even numbers? You'd be writing forever. You can't possibly list them all. And that is why we have this super powerful set builder form. See, instead of listing the elements, we just describe what they have in common. Here's how it's built. Step 1, you start with this basic structure, which you read as the set of all elements X such that. Step 2, you state the property they share. And step 3, you give it a boundary or a rule. And boom, you've described the exact same set as before, but without listing anything. It's way more elegant. Okay, so we can define a set. We know how to write it. Now things get really interesting. We're going to see how sets can relate to each other. And this brings us to the really cool idea of a subset. So let's kick things off with what we'll call our parent set. We'll call it set B, and it's got 4 elements, 1, 2, 3, and 4. Just keep that set in your head for a second. Okay, now check out this other set, set A. It only has the numbers 2 and 3. Now look closely. Do you see a relationship between the elements in this set, A, and our parent set, B? If you spotted that, yeah, every single thing in A is also inside of B, then congratulations. You just figured out what a subset is. That's the whole definition. We say that A is a subset of B, and we use that little symbol you see there to write it down. Now, when it comes to subsets, there are 2 rules that are always true, no matter what. First, any set is considered a subset of itself, which, makes total sense. But the second one is a little mind-bending. The empty set, a set with literally nothing inside it, is a subset of every single set. Kind of weird, I know, but it's a super important foundational rule in math. So if a set can live inside another set, what if you made a collection of all the possible subsets? Well, that's exactly what we're doing next, and it has an awesome name, the power set. To make this super simple, we'll start with this tiny set A with just 2 elements, 1 and 2. So think back to those 2 rules we just talked about. Can you figure out all the possible subsets you could make from set A? Give it a thought. All right, let's walk through it together. First, you've always got the empty set, right? That's a given. Then you can have subsets with just 1 element each. So a set with just 1 and a set with just 2. And finally, remember rule number 1, the set is always a subset of itself. So 1, 2 is also a subset. And that's it. That's all of them. Okay, here's the magic trick. What if you take all those subsets we just found, the empty set, 1, 2, and 1, 2, and you bundle them up into one brand new, bigger set? That is the power set. It is literally a set of sets. And here's what it looks like in practice. The power set of A, which we write as P of A, is this new set whose elements are our old subsets. Those subsets we listed are now the individual items inside this new power set. And get this, there's a really cool and simple formula for this. The number of subsets you can make is always 2 to the power of n, where n is how many elements you started with. So for our set A, it had 2 elements, so we get 2 squared, which is 4. And look at that, we found exactly 4 subsets. It always works.
So at this point, you might be thinking, okay, this is kind of cool, but so what? Is this just a game for mathematicians? And the answer is a big, big no. It turns out set theory is way more than just a classroom exercise.
See, set theory isn't just some random topic. It's like the operating system for so many other fields. It's the absolute foundation of logic and reasoning. It's crucial in computer science for how we build databases and design algorithms, and it's the starting point for most of modern abstract math.
And that brings us all the way back to the very beginning. It all comes down to this one simple but incredibly powerful idea. A well-defined collection of objects is called a set. Everything we just went through, subsets, power sets, it all flows from that one elegant rule. So I want to leave you with a question to chew on. Now that you know the secret rule, take a look around your own life. Your music playlists, the contacts in your phone, your to-do lists. Which of those can you now define as a truly well-defined set? Think about it.